Hey everybody, good evening. Welcome to session two of the Joy of Coding with Java and Android here at Portland State University. Once again, I'm David Whitlock. I'm the teacher for this course. And thanks for coming back for night two. You know, I never know, right? So hopefully last time wasn't too scary. Um, let's see here. Here's what we're going to do tonight. We are going to start our exploration of the Java programming language. And what we're going to focus on tonight is a series of coding activities called Koans that will give you a bite-sized introduction to all sorts of different aspects of the Java programming language, how to work with object-oriented programming, the Java APIs, really good stuff. So for me, yeah, I've got lecture materials to how to learn about learning the Java programming language, and if maybe it's been a while since you've done Java, or maybe you're really not feeling that cool foundations, that's okay. I think between the lectures, but especially this Koans project, it'll give you all the information you need to know to do the Java development here in the course. But first, I'd like to open up for questions. I usually begin class with a session that I call Prime Minister's Questions, where it's an opportunity for you to ask me the things about the things that are on your mind, things that we covered on Monday, things you've explored in between, questions that you have about the future. Any question is fair game, and I'll try my best to answer. Was everybody able to create a GitHub repository and run the survey program? Did anybody encounter any challenges running the survey program? That's a very important first step. As a matter of fact, you'll need to do that before the stuff that you're going to see tonight. So if you haven't done that and you have your laptop, hop on that right now. That basically gives you the prerequisite configuration and the ability to create the Koans project and then commit your changes to GitHub. So yeah, I encourage everybody to play along with that. And just as a reminder, all of that starts with the Getting Started repository, which was linked to in a couple of places. In Canvas, if you want to start there. I think I also put it on Slack there. And so then go through this Getting Started repository to create a clone, or sorry, create a new repository from this template and follow the instructions in the README. Nothing on your mind tonight? Perfectly okay. Good deal. Hey, it's nice to see a mix of people here in the classroom and remote. Just as a reminder, there are only 3 classes in which you are required to be here in person, and that's when we do our first pair programming experience on July 9th, our first mob programming experience on July 30th, and then the final exam on August 13th. All other class sessions you may attend remotely. I'll broadcast via Zoom and put the recording up there. However, history has shown that the students that come to class enjoy the course more, get more out of it, and get better grades. So I encourage you to use your time appropriately. You know how you can best learn, but I want to make sure that the material is available to everybody and that it's accessible as it can. Yeah. Okay, easy one tonight. Let's dive in. Okay, so the first assignment in this class are called the Java Koans. So it's occurred to me that this might be cultural appropriation, but the whole idea is that a koan is a teaching question that's used in Buddhist discourse. So grain of salt if you are a Buddhist or have experience or know people who are. No offense, is meant to be used as an analogy for a simple question that might have a complex or an interesting answer. So what we'll see here, we'll start tonight and then you'll finish on your own, is a series of very small pieces of code where you're essentially filling in the blank. where I'll say, hey, what is the right answer for this question? And the intent here is not just for you to get the question and move on, but for you to really understand what it's trying to teach you. I found this is a really great way to explore the Java programming language, to learn about the APIs, to learn about object-oriented programming in very little pieces. And then what you'll do in your assignments is take all those pieces and put it together. Now, this is not something that I came up with. It's actually adapted from some work of a guy named Matt Bentley and his original, the original koans can be found there. I've adapted it for this course, mainly just making it so that it plays in nicely with the Getting Started repository and things like that. It's really good, and this is an open source project, and people will contribute to it from time to time. And so there are a lot of these little koans. There's over 200 of them. And so then just little baby steps to get you started. So what we're going to do tonight is walk through getting started in the assignment. You can play along from home if you're ready to do so, or you can just watch tonight and then follow up on your own. Although I do want to point out that these are due on July 9th, which I believe is 2 weeks from tonight. That probably seems about right. Yeah, July 9th would be 2 weeks from tonight. So please start these early. One of the things that students have told me, especially with the koans, is that there are a lot of them, and that they really benefited from just doing a handful every day. It'll show you your progress, and so you can do the math to figure out how many you must do each day to deliver, to get things done on time. But I've also heard that students, once they get into it, they find it kind of fun, and will end up doing a lot of them at a particular sitting. Okay. So the instructions are here, but I'll just show you how everything looks like. Okay. So first off, we're going to log into the PSU machines. All of the is that correct? Yeah. All of the create scripts must be run from the PSU machines, just so that everything is nice and consistent. So I'm going to. Oops, I'm not going to log into that account. I'm going to log into my account. And here I am on the PSU machines. Okay, I don't need to see myself. And I'm going to, I'm going to go to my the checkout of my GitHub repository for the summer. So that was in Git, David Whitlock, Joy of Coding, Summer 2025. This is the repository that we created on Monday that I got the clone here on the PSU machine. This is where we ran the survey program. Let's get that me.xml file. Hopefully this is all coming back to you. So we've got a number of scripts here for creating various projects. Tonight we're going to create that kata project just by running // and // for anybody that you might have forgotten this about Unix. // means run something in the current directory. If the current directory isn't on your path environment variable, you might not be able to run it, or rather the command line won't find it. And so then I always prefix my scripts and stuff with // We are doing koans. Thank you. Yep. Good deal. And you should just be able to run it just like that. Okay. So there it is. It is creating the koans. So it's downloading things. So what this does is it goes off and it creates a new Maven project. So Maven is the build system that we use in this class for our Java project, called Koans, and it populates it with a bunch of code. So now if I do a git status to see what files have changed here in my repository, we'll see that it's modified this thing called the pom.xml file. And if we look at the difference in the pom.xml file, we'll see that it added a new what's called module for koans. And that module then is also a directory here which has all of the source code for the koans project. So I'm going to add that to GitHub to put it to Git to put it under revision control. And now if I do a git status again, it sees that there are all of these files there. And so then I've added all of the files in the koans directory. Oh, and also my pom.xml is modified, but it's not staged for inclusion. So I will add that to GitHub too, or to Git. And now all of my files, all my modifications have been added to Git. So this is good. I've created it here. So tonight I'm going to create all my files on the PSU machine, and then I'm going to check them out on my local machine because we're going to be using IntelliJ, which is an integrated development environment, IDE for Java, to do the editing and actually work with the koans. Okay, great question from Jaida. What does a pom.xml contain? So pom.xml is the configuration for the Java project. Well, we go into much more detail, I'd say like in week, I don't know, like 5 or 6 or something like that. There is a Maven lecture. Feel free to jump ahead if it's something that's interesting to you. Maybe you've encountered Maven or something called Gradle before. They have similar goals, but do it in different ways. The idea here is what you're telling the Maven tool is here's how my project is configured. It has things, and we can just take a look at the pom.xml here. Of course, you're looking at XML, so it might be a little hard to read. And by the way, is that big enough for everybody? Is that readable? Your eyes are probably much better than mine are. Okay, good. No, you can't. Okay, no problem. No. You and me both. Okay, I hope that's a little better now. I wish it was bold. There we go. Maybe that's better enough. The idea here is, actually maybe we could look at IntelliJ too, is that it has all sorts of information about, basically what a project does is it creates an artifact of some sort. And it has all this information, all this metadata about, hey, what licenses it use, who it is that's built it. You'll have an opportunity to edit some of these, a pom.xml file yourself when we do the pairing and the mob programming. Really, but this is kind of neat to know here on session 2. But really, you don't need to be worrying about this right now. The whole idea is that we have these creation scripts, we have these template projects, so that you can get started writing some Java code and not worry about the complexities of building all of the Java code. By the end of the term, you'll be more familiar with Maven. You'll feel more comfortable with it, but right here and now, I don't want you focusing on this as much as I do learning Java program. Great. You had me at, I don't need to know this. Gotcha. Okay, well, now that I've added all of the Koans directory and the changes to the pom.xml to my Git repository, I'm going to commit them to the repository. So all of these changes are now in version control with a new revision. I'm just going to say added Koans, let me just say add Koans project. Okay. And now that I've added them, here I'm going to go up to GitHub, and we'll just see the magic of Git push. So this is GitHub, right? This is where like the primary copy of my repository lives. Oh, and actually, let me just go to the one I created. So not that one. Joy of Coding Summer 2025. Awesome. So here's the repository that I created on Monday. And it's true, the last change to it was made 2 days ago. It has this revision number. And that's when I added the student project. Okay, that was the last time I changed it. And now, here on the PSU machine, I've made some local changes. So I no longer have any changes in my changes locally, but it is telling me that my branch, so the checkout that I've got and the branch that it's on, is ahead of origin main. So it's the origin repository, which is on GitHub. And then the main branch of that by 1 commit. Because yes, I made that 1 commit. I added the Koans project, and I committed it, but I haven't pushed it. It's even telling me, hey, use git push to publish your local commits, which I will do. So I'll say git push. And since git push is pushing to a remote repository, and GitHub requires authentication, it's asking me for the passphrase to unlock my key, my SSH key, and poof, there I did it. And now when I go and reload GitHub, it'll see that it's the revision I just made a minute ago, and that's when I added the Koans project. So I'm demonstrating this, and I'm sorry if this is like an old hat for you, but I want to make sure to reinforce that the code lives in multiple places. and gets pushed, and as we'll see shortly, pulled around. Is that a familiar concept to everybody? Has everybody studied that kind of thing before? Because I'm happy to go faster or slower if this stuff is familiar. Oh yeah. Ooh. Okay. Okay. Yeah. Let me build. That's a good point. I did not build before I pushed, which might have been a mistake. Um, oh, really? And did something fail? Did you get a build failure message, or did it just kind of warn about some things? The warnings are probably okay. That's exactly what you should be seeing. So good, good, good. Actually, yeah, good. Nice. Thank you for working ahead. First class, I'm always worried if it's going to work or not. Yeah, no, you are. You're yes. I think you're in really good shape. You're just a little bit ahead of where I am. Nice. Okay. So over here in the PSU machines, we've created the project. We have created the Koans project. We pushed it up to GitHub. Over here, so many Zoom windows. And now I'll go back over here to the left, which is where my checkout is. Joy of Coding, summer 2025. Okay, I'm going to log out of the PSU machine because I don't think I'll need that. It's not anytime soon. And okay then, so then I've got, actually we'll do an ls here. And here is my checkout. I don't have a koans directory. I'll do a git pull though. And what this will do is this will pull the changes down from GitHub. As you can see, it went and created a bunch of files when you do the git pull. And this is all about synchronizing your code across repositories. And Git is excellent at this. And so then it allows you to easily move files and make sure that everything that you have sort of structural integrity to your code base, that you get all the changes, not some subset, so much better than it used to be. So great. Now we've got all the koans directory right here. And as we were just discussing, if you go back to the assignment after you run create koans, then we can cd to the koans directory and run this slash maven w exec :java. And actually what that does is it runs the main Java program for that project. So we say maven w. So maven w is a script called the maven wrapper, which runs the Maven tool and makes sure that all the configurations set up and everything like that for the project in the current directory. So any directory that has a pom.xml, you can run Maven in, and we're going to say Maven exec for execute a program and execute a Java program. And so when we run that, that's going to invoke this, what's a good word for it? This testing framework, this framework for the koans. And this is what you need to do with the koans. It'll run the command line program, and it'll prompt you to do things. So it's saying, hey, there's this file about koans.java, and there's a method starting with @koan called find about koans file. Look within it for your first lesson. And then once you've solved it, save the file and check back here on the command line for your first lesson. So this is the way the koans work, is that there's a little main program that will prompt you to make changes to these files, and this is how you progress through them. And speaking of progress, it's telling you that you have completed 0 out of 268 koans. So there's lots of little pieces of programming to write here. So now this is where, okay, so any questions so far about sort of like how we get here? I want to pause to see if there's anybody who's playing along at home that has any questions or has encountered anything surprising. Nope. Nope. Okay, cool. Okay, so now we need to edit our .java file. How do you, in your other classes, what do you use to edit text files or code files? Vim, okay. VS Code, okay. Yep. Any Emacs? Does anybody use Emacs anymore? Use Emacs, right on, my man. Yeah. It's super fun. Yeah, right. It's anyway. Yeah. It was the '90s. What can I say? So excellent, excellent. Okay, 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 great. Someone's used IntelliJ. Yeah, we're going to use IntelliJ in this class. So IntelliJ is probably the premier Java IDE. VS Code works fine too, and I've had lots of students use it. I don't use VS Code, so I can't help you in it, although it's pretty much like IntelliJ. So now I'm going to show you how to use IntelliJ. So I believe IntelliJ is linked to in the README there, and actually it's also on the class homepage for tonight. Let's see here. Yeah, session 2. Oh, yeah, yeah. So here's how you can get an academic license for, yep, thank you. Sure, take my cookies. You know, you can get an academic license for JetBrains. They're quite generous with the tools they give you as part of that package. You know, start them young. So then that's cool. Big fan. I've been using them for years, and I really like what they do. They create a great product. So I'm going to start IntelliJ here on my local machine. So just give it a moment to load up. One thing to learn in this class is I have a really old laptop. It works great though, so I'm that guy. And sometimes things take a while. Oh, and by the way, yours will probably look okay, really different. So I've been using IntelliJ for a long time, and you know, they do things over the years like let's have dark mode by default, or hey, let's move everything around and have icons instead of words. And you know, people like myself who are old and set in their ways are like, I don't like that anymore. And so then mine might look very different from yours. Let me know if there's something that doesn't make sense, or that if you're struggling to translate between what you're seeing in my IDE and what you see in yours. If you want to go back to the classic look, you can install a plugin to do that. But anyway, when you open up IntelliJ, what I'm seeing here is all my recent projects, because, well, I use this all the time. You'll probably just see something that looks much more empty. And what you'll want to do is open up a project. So you click the Open button. And here's where we want to navigate to the checkout of our source code. So the whole idea is that we've got our source code on disk, and what IntelliJ can do is if you point it at the source code, it'll analyze it, and it will make sense of your code for you. It will basically figure out where all the code lives, treat source code differently from test code, let you navigate between all this stuff. It's really great. So then, if I then look in my PSU Git, David Whitlock, here I am, summer 2025, and I open up the pom.xml file. You have to be pretty careful about this, so please be sure. I'm going to reiterate these steps again. You want the top level pom.xml file, so the one in the Joy of Coding Summer 2025 directory, not the one inside Koans, not inside Student, not inside any other ones that you created. Open up the top level one, and then everything will get weaved together nicely. You know, there's usually a couple of students that inadvertently open up the wrong one, and things don't work as well. And so then, but if you open up the top one, everything should be fine. So you open up that, and it's going to ask you, oh, pom.xml is a project file. Would you like to open it as a project? And say yes, open it as a project. And then IntelliJ will go and analyze all of the Maven configuration and let you work within that very easily. So this is IntelliJ. It's off doing some things, and the status is down here at the, great, load the Maven project. Yes, please. It's off configuring things, so it'll analyze the source code. It will, again, identify all of the parts of it and let you edit things. So over here on the left is a navigation window to let you look at all of the files, really the code that's here in IntelliJ. I have it configured for project view, which gives you some nice abstractions over things, so you can see, you know, instead of seeing like a Java source file, it shows it to you as a class, things like that. Here at the top level, you'll notice that I've got two projects that are two directories that are bolded. So each one of these things are the directories that are on the command line. So if you look, you know, here at, let's move this so you can see side by side. Oh, I'm just going to quit out of this for the time being. I'll go up a directory. Here I am at the top level directory, and if I look here's all the same files here. So we've got like our our me.xml. The me.xml is right here. And we've got these directories like koans and student. And because they're bold, it means that those are sort of sub-projects of the top level project. So this is what, again, this is what IntelliJ gives you. There's a lot of intelligence about your Java project. So now I'm going to go. Oh, and then you can you can navigate through various things to find your source code. Right now we're editing the readme.txt file. It opened that one up automatically. But let's say you wanted to open up the pom.xml at the top level. Just double click on that, and then you can see all of the stuff in the pom. Question. What I did was open the JavaScript directory as project without opening the pom.xml. And Michael, I think you probably meant the Java directory. I don't know what JavaScript directory is exactly, but probably just open the top level directory as opposed to the pom.xml. Yep, yeah, actually the top level directory, the Joy of Coding Summer 2025. And did that seem to work okay for you? It might work okay. Okay, good. That's another option then. That'll probably be fine. So you can either open the pom.xml or open the directory containing the top level directory containing the pom.xml, and IntelliJ will get it right. It's smart like that. Great. Again, those of you who may playing along at home, anybody following along, encountered anything surprising? Okay, good. Nice. Okay. I'm going to go back to the command line again, and I'm going to run. Actually, I'm going to instead of using this window, I'm just going to minimize this window. I just want to right here instead. I'll go to the Koans directory, and I will once again run maven w exec:/java. Okay. So we're running the koans again, and let's remind ourselves what it's telling us. Okay, great. Go open the file, users. Okay, here we are, my checkout, koans. Let's get everything on the screen. There we go. Koans source beginner about koans. Okay, so koans source beginner about koans. I'm going to double click on that, and so now we can see the source code. Look a little small to you? It's a little small to me. Now this is where, let's see, does Control Plus work? No. This is where I always forget how to do that. View, this is when we're going to ask help. Oops, where's the help? There it is. Increase font size. Increase font size in all editors. Oh, there you go. It's, what is that? Control Shift plus, or a dot. Okay. Okay, well, that's kind of nice. Okay. Hope that's more readable. Apologize if the stuff over on the left isn't. Well, actually, I wonder, there used to be a presentation for it. I wonder if that would help. Question. Wait, I just downloaded IntelliJ. How do I get to the joy of coding in the SSH? Okay, so then what I did was I made a checkout, a git clone of the GitHub repository in my local machine, and so all the files are there in my local machine, and then I open up the root directory or the root pom.xml of the project. Tavon, did that answer your question? And if you'd like, okay, good. And do you want me to show you how to do that? Oh, and also there's some good commentary there. Good. Yep, just yeah, and that's what I recommend. Cloning it on local machine. I think we might have mentioned the last time there was a way to do this remotely. I don't know. I find that this works, and it's probably a good way to get started. Okay. This is good. We're working through things in real time. Let's figure it out. Okay. So now, it's saying there should be a method starting with @koan, and oh, there it is, find about, and it's called find about koans file. Look within it for your first lesson. So here we go. It looks like IntelliJ has not so helpfully, collapsed that. And it says the following. Okay, so there is a method. By the way, this is a Java class. If you haven't seen it before, maybe it's been a while. This is what they look like. It starts with a class declaration. It's got a name that matches the name of the file. And then it's got methods inside each one of these method declared here. And the method is annotated, and we'll learn about annotations later, with something called @koan to say this method is a koan that needs to be completed. Saw a question come in. First time installation IntelliJ, we need to set up the JDK manually when opening up the project. You do need to set up a JDK, and I believe it lets you download a JDK these days, and so you want at least Java 17 JDK. Yeah, probably I should go through the whole thing of so next time I'll make a note to just like blow away my IntelliJ installation, start over from scratch, so we can all experience that together. Cool. I'll leave this open. Okay, so here we are looking at our source code for the about koans file. And right now, this koan is failing. Well, why is this koan failing? Sorry? Yes, line 11. Actually, as a matter of fact, I think it even tells you here that, yes, line 11 may offer a clue. It does, because we are calling this method that fails. So what should we do to make it pass? Do what it says. Yeah, comment it out, delete it, whatever. I'll delete it like this. And now I'm going to switch back to the command line. And when I do that, you may notice that there's some text scroll by. And IntelliJ automatically saves the file when it loses keyboard focus. So when I went back to the, when I switched windows, the file saved, and then the little program here noticed the file saved, and then recompiled the Java code. And now we're on to another koan. So let's see here. Koan is considered complete when it no longer throws an exception. Often there is more than one way to solve a koan, but only one correct way. This is often hinted at within the koan itself or the comments appearing here. Okay. Ponder what's going wrong in the about koan's definition of koan completion method. Okay, line 18 may offer a clue. So once again, it's failing on line 18, and while I take this question, why do you think it's failing? Yeah, it's expecting the Boolean to be true. So what can we do to make this pass? Yes, make the value of this to be true. Oops. Okay, I like this question that Michael asked. Is fail a function by the library beginner, or is it an STL, the standard API? Great question. The way you can find this out in IntelliJ is by command clicking, control clicking, or saying, or right click on it and then say go to declaration or usages. This brings you to a different file, which is the assert class, and tells you that this fail method is defined in the assert class. If you scroll up to the top of the assert class, you'll see that the assert class is part of this com sandwich util, and com sandwich is that is the framework for the koans. So just the same way that we're going to hover over the koan class, and you'll see that it's in the com sandwich package. So Matt Bentley, he is sandwich.com apparently, and unless the Subway guys got to him. But anyway, he called the package, the library that informs the framework, the infrastructure for the koans com sandwich. So to answer your question, it's not a standard Java code, and a standard Java method. Instead, it is part of the library that runs the koans. So that's what the @koan annotation is, and that's what the @fail is. So yes, the question is, so you have to include the koan class. You have to annotate it with @koan for each function that you want. That you want to be declared a koan. Now you're not going to be writing koans. I want to be clear. So you're not going to be writing new methods that have @koan. Instead, what you'll be doing is taking existing methods and making them pass. But you will be seeing next time when we write unit tests that there's a similar pattern here where you have a method, you put something called an annotation on it, and that annotation is a cue to a CUE cue, is an indicator to a framework like the Koans runner here, that this is a method that should be treated specially, should be treated as a koan. Great questions. So we changed the value of this this variable assignment to be true, and the way we know we changed it is that there's a little blue bar here in the margin. This blue bar here means that there was a change on the line. And the reason IntelliJ knows there was a change on the line is because Git can tell you that there's a change on the line, right? So as you make a local modification, Git will tell you that there was a local modification. IntelliJ reflects this back to you by putting a little blue, this little blue marker here in the margin, so you can tell where you've changed. Blue means change. If you add something, a new line, it's green. If you delete something, it's if you. Right, so yellow is change. Oh wait, what is yellow? Yellow is white space only change. That's right. And if you delete a line, then you get this little. I guess we had it back there. If you delete a line, oops, there's some stuff messed up here. If we delete this line, then you get this little. Anyway, I know. Thank you. Then you've got this little triangle here, and when you click on the triangle or the or really any of these change bars, any of these change indicators in the margin, if you click on it, it will tell you what changed. It'll tell you, aha, this value used to be false, and now you've changed it to true. It's one of those things I like about IntelliJ, right? It helps you answer your questions very quickly. And I encourage you to explore as you begin to use IntelliJ, to explore what it is that things do when you click on them, or when you right-click on them. You can find out things about them. Okay, so actually this is bothering me. I want to have a line there. Stop it, AI. New line there. I don't need this anymore. Oh, and by the way, when you click on it, you can use this back arrow thing to roll back to revert the change. I can do that, so that way instead of, I don't know, it was a couple spaces for an indent, now it's just an empty line. Okay. Meanwhile, let's go back to our koan. Go back to the command line, and we'll see that some more koans have taken place. Okay. So now we've done both of the koans in this class, and now it's moving us on to a new class called about assertions. So this is good. We've made some progress. If we hadn't made progress, we would still see that we were on that same koan. And by the way, we've now done 2 out of 268. So not even 1%. Not even 1%. Before we look at about assertions, I want to show you something else that you can do in IntelliJ. So I made a change. And one of the things that I like to do is commit my changes kind of early and often. Like once I have my code at a stable point, I want to commit that change because I know that it works. And then this helps me, this gives me some confidence that, hey, if I make a bunch of changes and I just break things and I'm unhappy with them, I can simply revert back to what was there in Git before. And you can you can manage, you can interact with Git and even GitHub here right in IntelliJ. And you'll see me do this a lot in this class. That's how I prefer to work with IntelliJ. Other people work with Git. Some people are very comfortable in the command line. It's not that I'm not comfortable in the command line. It's too slow for me. I think it's really fast to do things like this in Git. So I go to the commit tab over here, and I can choose the file that I want to commit. I want to say, hey, I want to commit my changes to about koans, and then I can put the commit message in here, and I want to say got the first 2 koans working. I'll say passing. I'm really excited, so I have an exclamation point apparently. And I can commit, or I can commit and push. So commit was commit to the local repository, or I can commit and push up to GitHub. So I'm going to do that. I'm going to commit and push up to GitHub. And oh yeah, it gave me a little warning here. There's some things it didn't like. It's I think it's this gray right here is warning me that there's a public method that's never used. That's okay. It doesn't realize that a koan is like a special method. And so yeah, I'm going to commit and push anyway, despite there being warnings. And now it is pushing it up to GitHub. And the way you know this is that it's saying, hey, it's pushing the main branch here locally to the origin main, origin. Actually, you can click on it. Yeah, and okay. It's a remote repository. It knows that. And the commit message was got the first koans passing. So I'm going to push that up. And so now it commits it, it pushes it. Notice there are no more change bars because there are no local changes to this file. And if I go up to GitHub here and I refresh, yep, sure enough, just now we had a commit of, got the two first koans passing. So this is the integrated development environment. You can do all of this stuff just right there from your IDE. And I'll say the advantage of it is that it's fast, right? You don't need to go between different windows. You don't have to take, you don't have to start typing. As a matter of fact, one of the things that you'll see me do more and more in the class is use the keyboard shortcuts. I don't know. I ain't got time for the mouse. I just want to type, had everything work. You may have noticed that when I do certain things with IntelliJ, there's some bubbles that pop up down here that show you keyboard shortcuts that I could be using, and also when I use certain keyboard shortcuts like Command K for commit, it'll pop it up down here. It's a plugin that I have installed, and hopefully that's helpful for you to show you either what which key combination I'm using, or what keys are available to use keyboard shortcuts. Okay. Any questions about what you've seen so far? Have you all had an opportunity to use IDEs before? I hope a little bit. Yeah. Okay. Good. So, hopefully the concept of using an IDE is familiar. I acknowledge that's some of the navigation that we're doing, certainly the Java focused things, and using your IDE to do commits and things like that might be a little new to you. So feel free to ask questions if things go too fast. Okay. Yes. And as a matter of fact, you'll be ignoring those warnings forever. And so, yeah, I'll just say another thing about that. So, hey, IntelliJ is trying to be helpful. And one of the things that it's helpful about is saying that, hey, you've got a method and no one's calling it. Now, that's dead code, right? And so normally you wouldn't want it. And so IntelliJ is, again, being helpful and saying, hey, you got some code that's probably dead code. Do you want to delete it? And sometimes the answer is yes, but in this case, the answer is no. And the reason it doesn't know that it's important is because, well, IntelliJ doesn't know what a koan is. It doesn't know that this is a meaningful method. When we start looking at JUnit, unit testing, next week, we'll see that if something's annotated with @test, IntelliJ knows what @test is because JUnit is a very, very popular framework, and so it has built-in support for saying, oh, if a method is annotated with @test, well then it's not, it's not a dead code. It's actually code that you care about. Okay. So now our koans are telling us something. Okay, so the two underbars are an attempt to communicate the need to fill in an answer. Judging by context, what should the two underbars be replaced with? Okay. And it's saying ponder what's going wrong in the about assertions class assert Boolean true method. And line 13 may offer a clue as to how you may progress on my case. So what went wrong? We expected something other than underbar, but what was underbar? Well, let's go look at this about assertions. So about assertions, let's go back over to IntelliJ, back to our project view. About assertions is still here in this beginner package. And oh, here it is, number 3 in alphabetical order. Here's about assertions. Okay. So then, there is this koan right here called assert Boolean true. So we are calling this assert true method, and right now we're sort of giving it a fill in the blank. There is no value here. There are two possibilities, true or false. What should it be here? So what should it be there? Yeah, survey says true. So yep, so what we do is we replace the two underbars, again it's fill in the blank, and you say with true. Okay, now let's go back to the command line. Oh, we went from 2 passing to now 3 passing. Ponder what's going on in about assertions, assert Boolean false method. Okay, what do you think this one is? Yeah, let's try false. Okay. And went from 3 passing to 4 passing. Super sweet. Okay. So again, what this assertion is all about. Oh yeah, what this assertion. Oh, sorry. What this koan is all about is these assertion methods. Now let's see here. Tavon asked a question. I'm not seeing any progress, even though I did commit and push. Okay. I think I know what might be going. Well, let's see here. Didn't see any progress. You did a commit and push. So then there could be two things. Here's something that people tripped that tripped people up last time that that I learned and tried to emphasize. So unfortunately, the way that the koans work is that I think it's here in the app class. There is this app data source directory which has a copy of all of the Java classes. Is it possible you edited one of these? Because if you edit one of these, it actually doesn't have any effect on things. So Tavon, could you check that out? And the reason I'm diving into this is because it's something that it tripped up a couple of people last time. So I think the first thing to look at is, oops, did I inadvertently change a different file? And actually, and Tavon, and please correct me if I'm saying your name incorrectly. Um, uh, if you'd like to work through this in real time, I'm happy to do it with everybody here so that we can all get you back on track. But if you could, please come off mute so we can talk about it instead of just having a text.
Yeah, sure. It is Tavon.
Tavon, thank you.
Yes,
Yep,
and then no, I'm in the source beginner. I
good.
didn't go to apt
Yep.
because it has the C next to all
Yeah.
the abouts. So all
Okay.
that stuff looked correct. And then yeah, when I committed and pushed, it looked like it all worked. I checked on my repository and I see that um the repository did push, but I think it might be something the fact that it's on my local machine that it didn't update it or
Yes. Okay. And so then, are you running? Are you running the command line program, the Maven Java? Sorry, the Maven W exec Java. Are you running that on your local machine or on the PSU machine?
the PSU machine.
Aha. Right. Okay. Good. So that makes sense. So basically, you're working on your local machine, but you're checking to see if the changes are there on the remote
On the
machine.
remote, I see.
Yeah. So what you'll need to do is well, probably just log out of the PSU machine and then run the Maven W command on your local machine in your local checkout. And I think that then you will see that as you change the koan source files, then the change will automatically be detected.
Okay.
Nice. Yep. Good learning. Thanks, Devon. Okay.
Thank you.
Yeah. So this about assertions koan introduces us to all these different assert methods. So assert true, assert false, assert null, et cetera, et cetera. We'll look at them here shortly. So an assertion is, well, it is a statement of fact. And if that, or a statement of what you believe. And if what you believe turns out to be incorrect, then the assertion fails. So you're asserting that something is true. So for instance, here we are asserting that, well, the Boolean true has the value of true, or that the Boolean false has the value of false. But you can also put an arithmetic expression here, like, 2 plus 2 equals 4, right? You can do those kinds of things because 2 plus 2 equals 4 will evaluate to a Boolean type, and so you can assert whether or not that, that Boolean expression returns true. So let's work through some more of these here. Okay, so assert null object. So here we are saying that, hey, we want to fill in the blank here with a value that that is null. So does anybody know how to do that in Java? Yep, all lowercase null. Yep, let's go back and make sure we go from 4 to 5. We are. Okay, next is assert null object reference. Okay, so a little bit more complicated. So now we want to assert that we're going to fill in this blank here. And so what can we fill in here to make the assertion on line 31 pass. Yeah. Again, we have an object reference. We have a variable that has a value of null. Nice. And I will note that like IntelliJ is telling you, hey, the value here is always null. In normal code, that's probably not what you'd want to do, or you'd want to know about that. Here is the koans. Yep, you're learning. You're going step by step. So things uh, are simpler. Don't worry about all of the warnings for now. Once you start writing your project code, then the warnings will become more meaningful. Okay. Here we have a koan that says assert not null. So right now it's failing because we're passing in null. So what should we pass in here instead? Yeah, some object. So like, what's a good object to put in there? Oh, put underscore underscore. That's interesting. It's not well. Yeah, you're not actually supposed to write underscore. That actually does that work? I wonder if that works. From 6 to okay. Yeah, it's not really the intent though. Um, okay, a string. Okay, yeah. So string. Hello. Hello world. Thank you, AI. Okay. And I think it'll still pass, right? Yeah, it still passes. Okay, now assert equals using expression. Okay. Oh, look, it's hello world again. So here, what do we need to change this to? Yeah, hello world. And actually, this is kind of a good example. Hello world. Thank you, AI. So this is using the equals method. So you'll learn about this in the Java lecture, in the Java language review lecture, if you didn't know it already. Every object in Java has a method called equals that compares that object, the object that receives the equals method, to some other object, some other value. And when the two objects are logically the same, it returns true. So yes, here we want to say that hello world, when you invoke the dot equals method on the hello world string constant and provide it with a hello world string constant, it's the same value, they're equivalent values, this returns true. So now we've got 8. And of course, if we change it to like hello class, IntelliJ lights up because it's like, those aren't equal. Yeah, right. Thank you. And now it'll go back to 7, failing because once again, it expected true but was false. Let's undo that. There we go. Okay. Okay, let's see here. Oh, there's also the assert equals method. So again, this assert true, this assert equals, this is all part of the koans framework. You'll be using all of these, you'll be seeing all of these methods throughout the koans. And this early koan about assertions is teaching you about all of these things and how to use them because you'll see them so often. Again, it's fill in the blank. So, sing along. Assert equals of hello world equals is. Hello world. Okay. So assert equals works with any object. So it can work with a string and also work with int constants like this. So assert equals of 1 equals 1. 2 plus 2 is 4. Yeah, right. Yeah, you can do that. You can also say, yep, you can do all this. So 2 times 3 is 6, and look, basic arithmetic operators. 3 minus 8 is, yep, minus 5. And 10 divided by 2 is +5. So I'll just make sure all of that worked as expected. We go from 7 until 9. Yeah, we had on that one. Great. Now it's assert equals with descriptive messages. Oh, yeah. Ooh. Did like Was there an error on the command line? Yep. Yeah, and here again, IntelliJ is like, hey, oh yeah, exactly. It equals is called on itself. This is probably not what you want to do in your code, right? If you end up comparing two values, I mean, this is kind of a nonsensical thing to do. And so IntelliJ is being helpful, right? It's like, hey, hey, human, maybe you didn't want to do this, which is good feedback and stuff. But it can also be overwhelming, also be a little confusing. It's like, well, am I supposed to act on this or not? Right. So I think again, while if you see something like this while you are developing your projects, then yeah, you probably want to pay more attention to it. You want to understand why IntelliJ is telling you that because it's probably that warning is probably there for a reason. Here, IntelliJ doesn't realize that these are like little baby steps and stuff, so it's treating this code as if it were like production code, not like the teaching code that it is. Okay, let's keep going. Ah, yes. Okay, there is a variant of the assert equals method that takes 3 arguments. So up here, all these were 2 arguments. It took the expected value and the actual value, and if they didn't match, it failed. Here we have 3 arguments, and so the last 2 are the expected value and the actual value, and then the first one is a string message that tells you some more context about the assertion, and so when it fails, it can tell you a little bit about it. So, for instance, here, line 60 failed, and it says what went wrong. Well, the answer to life, the universe, and everything should be 42. And so then, well, it expected 42, but you just passed it I don't know, fill in the blank. So we got to fill in the blank to have it be 42. And now when it does it, yep, that one passes. And this is helpful, right? Because here, when it failed, it gave you a little prompt to tell you, more about what the assertion is. Okay. More assertions. Okay. There's assertion. There's assert equals, and there's assert same. So there's a difference between 2 objects being equal and 2 objects being the same, and this is meant to point that out. So there is a type in Java called capital I integer, and this is different from the primitive type int, which is 1, but you can create an integer from a 1. By the way, this code is going away, so it is at some point you won't have a new integer constructor anymore. You do for the time being, and so we won't worry about it for right now. But IntelliJ is yelling at you about it. Oh, Michael has a question. I am confused about the error message because when it states expected something other than underbar, I'm thinking any other characters, but underbar, so we'll be writing like 50 words as an example. Yeah, okay, so think of underbar. It's actually a variable. It's a global variable. If you look at the implementation, that's really not the intent of what it is. Sort of like take a step back and say, hey, this is just a value I need to fill in. And so when you see underbar, the intent is that in the Koans, you change it to something else. So that's what underbar is. It's like, hey, imagine you're doing Mad Libs and you write in all your funny things. And so that's what the underbar is. Yeah. And and actually, okay, and something else, yeah, I should mention. Originally, originally the when you were asserting something like, well, I'm just going to undo this one again. Okay. Originally, it would print out the answer to life, universe, everything should be 42 because here it is in the string, and it used to say expected 42 but was underbar. That kind of gave the answer away. And I think it's made it too easy, and it discouraged students from thinking about what the answer should be. And I think some students just made it easy, just like, oh, let's paste in the answer, and then pasting didn't always work the way they expected, and that got that was confusing for them. So I changed the Koans framework to say, hey, I wanted something other than underbar, but then I was underbar. And now, if I say, hey, I said 43, then it would tell you that it expected 42 but was 43. So if there's something that you're stuck on, I'm not going to give you the answer the first time. Just put in some random value, and it'll tell you what it's supposed to be. Right? I'm not going to make it super tricky for you, but I don't want to make it super easy. Okay. So we'll go back to 42, and we'll see that now we've got 10. Okay. Now, as assert same instance. As I was saying earlier, every object has a dot equals method. And what dot equals is a logical comparison between two objects, which means do they represent like, two things that are equal. So for instance, as we saw up here, two strings that have the value hello world, they are equal. Yep, that makes sense. It's the same string. And so then these two pass, correct? I think it's complaining about line 72. Yeah, it's complaining about line 72 because here's where the underbar is. And so then the variable original and the variable different are both equal because they both refer to the integer, capital I integer object that represents the number 1. Great, those are the equal. But are they the same? What is the object here that is same as the original? Is it same or is it different? So which one of these points to the same object? And so same is different from equal. Same is like, are they, if you think about Java as having pointers, but if they refer to like exactly the same object that was instantiated. So what is the same as original? Yeah, the same variable. Yep. Yeah, it's the same memory address. It is the same object there in memory. There you go. Same value versus same reference. Yep. So original and different have the same value or have equal values. Let's use the Java terminology. But original and same have the same reference or the same reference. So it passes. We go in 11. If we change this back to different, it'll fail, and we'll go back to 10. And although, look at the message is a little misleading. It's like, well, I expected 1, but it was 1. But why doesn't this pass? Well, it's because it's asserting the same object. The same object as original is same. This is what the koans are meant to do, right? They're meant to teach you about little concepts within the language. And I encourage you to just take a moment and play with them. Figure out, okay, well, what do we do to make it pass? What do you do to make it fail? Okay, the last one in this file, assert not same. Okay, there's an assert not same. So right now this is failing because it's saying original is not the same as same. Well, we know that original and same are the same from the above one here, so we just want to change one to different. And go from 11 passing to 12 passing. Yay! Okay, so those are some of the koans. So I've reached the end of another one. I'm going to commit. So I'm going to use the keyboard shortcuts. I'm going to say Command K, and I'm going to say got the second batch of koans, second suite of koans passing. And I am going to use Option Command K to commit and push. Warnings, yeah. I'll push that up. Excellent. Okay then. Is this making sense? Sort of what the koans are all about, right? Learning little pieces. Okay, good deal. Well, we've been at this for an hour. I think it's time for a break. So let's take 12 minutes. We'll pick it back up at 7:15, and we'll do some more koans. Continue to work through this, see more things about the Java program. Awesome. Okay. Hey, I see some good stuff happening in the chat. Thanks for helping each other out for what you see. And hey, this is just all, remember, this is the second class. There's going to be stuff here that doesn't work right away. And here again, I've got like my IntelliJ all set up and everything like that. And, of course, I'm very familiar with the environment. And I'm working on a Mac. Like some people that are working on different platforms will encounter slightly different things. So thanks for helping each other out and making sure that people are successful. And of course, if there's anything else that you run into after class, please post about it on the class Slack channel. and I'll try to respond as quickly as possible. Although I work during the day, and so then I am most likely to respond first thing in the morning or in the evenings. My daytime response will be limited unless you just happen to catch me at a time like I'm on my phone and I'm not in a meeting or something. Okay. So in the first part of class, we started exploring the Java koans. Any thoughts during break people like to share? Any ideas, any questions, anything that people like to bring up? Oh, that's cool. Okay, so we finished this about assertions koan, and now it's telling us to move on to the about equality. So okay, let's look at another one here. So about equality. Oh yeah, this is more stuff about equals versus same versus things like that. So here we are. Double equals tests if two objects are the same. So we've got two objects. And actually, so this is an interesting example. So Java Lang object is the root class of all types, of all classes in Java. Everything is an object. Um, and the nice thing about Java Lang object is that there are some methods that are on Java Lang object and therefore are inherited by all classes, by all types in Java. So things like equals and hash code and toString, which you'll learn about in the lecture and stuff, and we'll see here in the koans. But it's nice to have all of the objects have a common ancestor. However, because it's like so generic, you really can't do much of anything with it. So it's not like you'd use it that much in your code, but this is a good teaching example of how to work with object. So we declare a variable called object, which is a new object, then same object, that then refers to that object class. So, and this is about using the equals operator, which tests to see if two objects are the same. So, and equals returns a Boolean. So are we saying, hey, does object equals same object? True or false? Getting a thumbs up for true. Okay. Not just doing your Fonzie thing. Kids know who Fonzie is, right? Fonzie, right? No, okay, excellent. This is progress. Oh, okay, because yeah, some of us are of yes. Anyway, the guy who jumped the shark. Okay, there we go. Maybe even that's a dated reference, right? Okay. Was that what? More obscure. Yeah, right. Yeah, more obscure. Nice. Anyway, and that passed. So now it's saying that line 15 may offer a clue. So yes, so equals tests to make sure that they have the same value. Sorry, the same reference. They have the same reference. And so then does our object over here equal, is it the same as another object? No. AI says false. AI is correct in this case. Good. Now we're down on line 21. There's also the dot equals method. Okay, so dot equals, we saw that before with strings, right? And how dot equals will compare two objects to see if they have the same value, not the same reference. So, does an object equal itself? It better, right? It's like, okay, you'd expect it to. And so, yes, I would expect the line 21 now passes. Yep, now we're on line 22. Does an object equal another object? I don't know. Yeah. Oh yeah, I'm going to say false also. Let's see if that's correct. Line 22. No, on line 28. Yep. So, and here again, this is what the koans do. They sort of ask a little question. You think about it for a little bit. You try something. You see if it works. And then if you don't understand why it worked, well, why it did work that way, hey, try some other things to understand, and then maybe do a little bit of research, that kind of stuff. Okay, excellent. Here is another koan all about dot equals. So now I have an object that is an integer. And note that I can assign an integer to an object class, no, sorry, assign an integer, a capital I integer type, to a variable of type object because in Java, all classes extend from Java Lang object. All objects are a Java Lang object. So this is a completely legal assignment right here. Okay, so now I've got an object. And does that object equal itself? Right, we already decided that yes, it did. Let's make sure it's true. So line 28 passes. Yep, now line 29 fails. Okay. Does an object dot equal a new integer, a different integer, with the value 1? So are these equal to each other? What do you think? What would you like to be true? Like, what would make sense? So, like, if you were, the author of the Java programming language, if you were writing this, like, what would make sense to you? Would you want an object that represents the number 1 to equal another object, a different object that also represents the value of 1? I think you would. Yep. And so then, we would expect this to be true. Good. And it was. So what you'll learn about in, I don't know, in a lecture next week or the week after, is that Java Lang integer, like many classes, overrides the equals method, which means it defines its own version of the equals method that knows how to compare itself, a Java Lang object, sorry, a Java Lang integer, to another instance of Java Lang integer. And then you do the thing that makes sense. You say, oh yeah, what's the int value of that other object? What's the int value of my object? Are they the same? Great, then we are equal. Just the same way you can compare two strings back in, what was that, about assert equals, yeah, just like here, the dot equals method of Java Lang string, so this constant right here represents an instance of Java Lang string. Java Lang string overrides the equals method so that if you pass in another string, they then compare character by character to say that yes, those are our equal strings. And this is the way object-oriented programming works, right? You've got superclasses, you've got subclasses, you override methods to provide functionality that is customized for the subclass, that is refined, it does something more interesting than what you inherit from a superclass. Okay, here's another example that talks about equals. And you're probably getting good at these by now, so let's see if we can go a little faster. So here we've got a value 1, which is a new integer of 4, value 2, which is a new integer of 2 plus 2. Are those two objects equal? Yeah, very good, because they both have the value of 4. And here we can say that value 1 is equals, and I think value 2 is probably what they're looking for here. You could also put like the number 4 there or whatever. So I think you should pass that. Yes. Yes. Okay, line 44. Line 44. Oh yeah, line 44. Now that I expand it. Here's something interesting. So okay, the title of this koan is Objects Never Equal Null. And so then assert equals, so does a new object ever equal null? No. It's false. I'll go off script here a little bit. What happens if I say this? So does null equal oops. Oh, that's interesting. It doesn't work that way. I got to put this into a variable. So I'll say object null object equals null. That's nice. Null object. Great. And I'm going to do underbar underbar. What's the value here? Does that null object ever equal a new object? Right? I think it should be false. Okay, good. Let's put false. And it's false. Okay, so now I'm going to run this. And whoa, what happened there? All sorts of stuff is blowing up. Okay, let's take a look. Object is never equal null. Line 46, something went wrong here. What went wrong? There was an exception. So invocation target exception, null pointer exception, cannot invoke object.equals because local 1 is null. Okay. So here's something about Java. If you try to invoke a method on a null object, something called a null pointer exception is thrown. Are you familiar with exceptions? Have you learned about those in C++ or in Java or in Python? You know what an exception is? Okay, right. So the whole idea here is that when something very unexpected happens, instead of getting a segfault or crashing or blue screen of death or whatever, object says, oh, wait a second. Sorry, Java says, oh, there is a this exception thing which gets thrown. You find out the stack trace, you can see which code calls itself and everything like that. So this is what happens when you try to invoke equals on null, because the null object doesn't have any methods. There's no object there to invoke a method on, and so you get a null pointer exception. Get that back passing again. Oh, there it is. Great. Okay, now line 50. Oh, okay. Objects equal themselves. Well, so I think we already did something like this. So does an object equal the same object? Yeah. Yeah. I think what might also be interesting is this one. So doesn't I maybe we already did this one. Did we already do this one? Object equals a different object. Maybe we did. Fingers. Oh, I guess we already did that one. Yeah, so I don't know when we have that one down at the bottom. But the whole idea here is that object does not override the equals method. Actually, if you look at the implementation of the equals method, which we can do by saying go to declaration usages, here is the implementation of the equals method on object. You can look into like the source code of like the Java classes, which is super cool, like the standard Java classes. And what it does is says, listen, I'm only going to be, the only other object I'm equal to is myself. So the keyword this refers to the object on which the method was invoked. And so basically it's saying, hey, listen, I am only ever going to be equal to some other object unless that equal is the same as me. Which actually is pretty reasonable behavior, right? It's okay, great. It's only equal to itself and nothing else. And then it's up to the subclasses. And what happens when I click on show me all the subclasses? Oh, that was probably a dumb thing. There's like 1,000 of them. Okay, never mind. It's only if you look at well, let's look at Java lang string. Java lang string, and then we can navigate to. Oops, that's not what I wanted. I always put the keyboard shortcut in there. And I can navigate to the equals method. Here's the equals method of Java lang string. And we say the following. We say, hey, listen, if it's the same object, so if this other object is the same as me, then great, yet return true. Otherwise, we say, hey, listen, if that object is an instance of a string, and then we do all this other crazy stuff like, oh yeah, hey, make sure that they're all the same value, then yes, those two strings are equal. That's how it does it. All you care about is actually what's captured here in this documentation, which is probably a little hard to read. There it is. Now it's easier to read. It basically says, hey, listen, compares this string to the specified object. The result is true if and only if the argument is not null and it's a string that represents the same sequence of characters as this object. Neat. Anyway, IntelliJ allows you to navigate to any source code really easily. And I don't know, in probably when we talk about your project one, which will be next Wednesday, we'll see how you'll be able to navigate from your code that you're writing to my code that I wrote for you to leverage very easily. But meanwhile, we've finished off another koan. Oh, and the chat went away. Um, and yeah, there we go. So now we are on to something else, right? About equality. Oh, no, wait. Well, we didn't get this one working because I added it and didn't need to. Yep, now we're about strings. Cool. Okay, we will commit this. Oh, and by the way, any code that I write in front of you is yours to use. So hey, if you don't want to take the whatever, like, 5-7 minutes that'll take to go through these first couple of codes on your own, just want to copy, go get my code from GitHub and copy it in. That's absolutely fine. But also, it's pretty easy just to go through this stuff yourself and reinforce the lesson that you learned. Okay, let's just do a couple more. Let's see here, about strings. So we'll go back here and say about strings. Okay. Oh, this is interesting. Okay. Gotcha. This one, this is a really advanced thing to have so early in the koans, and it usually trips people up. So I'll go into details about what it is here shortly. But a question came in: is it mandatory to only change what is underlined, like the underbar underbar? I'm just wondering so I don't change the main objective. Thank you. Yes, Michael, that is the intent. That what you do with the koans is that you replace the underbar underbar with something else. It's not until you get to the kind of advanced ones where you might need to add other code. Um, Resist the urge to delete the assert method. I think that makes it pass, actually. Let's find out. Let's see here. Say what? Yeah, exactly. Yeah. Yeah. I wonder how many students have done that over the years. Yeah, it passed. Okay, I need to fix that at some point. Yeah, I mean, I probably need to, say it's, how do I do that? I would have to, set some sort of flag and say, yes, an assertion was called, and an assertion wasn't called, then it would fail. But anyway. Okay. So, assert equals just a plain old string, dot get class equals what? So, let's see here. I think you all know enough about object-oriented programming. You've got an object, and an object is an instance of some class. Right? The class is like the template or the blueprint for what the object can contain. Each class has a name. It defines fields and methods. So it's got state, it's got behavior. Right? It's the whole thing. Another method that is inherited from Java Lang object is a method called getClass. And getClass returns an object that describes the class of the object on which it was invoked. This is part of something called the reflection API, which is a really advanced concept in Java, which many years ago I included in this course, and I realized that it was just not really that relevant. It's super fun. I think it's super cool. You can do really, really powerful things with it. But it's not like it just didn't make sense to cover in this class. But the koans still have it because I think it's something good to know. So does anybody know what the answer to this is? How to represent the class of a string? No, here you go. String. Great. It doesn't like it. What doesn't it like about it? It says expression expected. That's true. This is not an expression. This is, it actually would be a variable in this context. But you were close. You say string.class. This is special syntax that refers to the class object for string. I think the only time you're going to see this, actually no, it's not true. It's not the only time that you'll see this in the course. You'll actually see it maybe next time or the time after. So we do use it a little bit, but this is one of those times where, hey, listen, it's the second class, just magic in a way, right? Okay, this is what it takes to get it to work. Because you will see this syntax a couple of times in the course, and what you need to know is that this is how you talk about the class of something. This is the the string class. It represents it this way. And so there's two ways to get it. You can just say here in the just using this language syntax string.class, and then you can also say I've got an instance of string, I've got a string object, and when I get its class, what I get is the string class. So that was line 15. Line 15 now passes. Now we're on to line 24. Okay, more stuff about strings. Now, oh yeah, the comment here points out that you don't, in the code, you very rarely actually like instantiate a string object straight up. Usually you have a string constant like this in your code. But this is talking about the equals method. So let's see here. I've got a string that was a new string. I've got a string, the empty string. Are those the same? Yeah, I'm getting a head nod over here. Maybe just rocking out. It's got the Motley Crue going on, the headphones out. Yep, and that passed. And so now we're on to line 31. So yes, you have, so basically when you create a string with nothing in its constructor, you get the empty string. Let's see here, question came in. Whenever we see an assert equals, do we always want to ensure we don't completely copy the left side to the right side? That's why we use string.class. Yes, that's correct. You bring up a good point, Michael. We could have also, and I'm just going to go back and work on this one again. I make it back to underbar. So we're going to go back to that one, and so that one is failing now on line 15. Now we could say that just a plain old string dot get class is equal to just a plain old string dot get class. This will pass. But did you learn anything? No. And hey, if you find yourself doing this a couple of times, here's what I recommend that you do. Hey, get to work, move on, but also make little notes like, hey, ask Dave, what was this one supposed to be? Because the correct answer, and here again, I don't recall if this is mentioned in the lecture. It's probably not. Oops, not sting.class. You're rocking out to the police. You'd say string.class. Is what we had before. Yep, still passing. Yeah, let's keep going. So we're learning more about the string class and the string constructor. So here we have a class whose, we have a string of the value 0. We create a new string from that other string, and we ask, are they equal? And are they equal? Do they represent the same string? What do you think? What would you expect? So they would, right? Because it's both, a string that represents the text 0. Let's try that one out. Yep, that passed. Now are strings the same? And as a matter of fact, IntelliJ is giving you some good hints here. It's saying string values are compared using the equals, not dot equals. Oh, well, that's probably not exactly the right thing there. The best hint. But actually, that's let's get this working. I'll come back and talk to that. So you've got a string that is the text 0. You create a new string object from that text 0. Are they the same? I don't think they are, right? Because you're creating two different objects. The constructor is, this is a new object right here. This is a different object. I think they're different. I would be right. What was I going to say before? Oh, yeah, equals. Okay, so if you're coming from Python or JavaScript, you're used to equals doing a logical comparison as opposed to a pointer or a reference comparison. I think I got that right? Python is equals. It'll sort of do the expected thing if you use equals in Python with two objects, two strings, right? But in C, for instance, if you remember C or C++, actually does C++ have equals? Does that work on strings? So it does. Oh, that's so confusing. Okay. C++. Okay, so then if you've ever done anything with C, so like think back to like the 70s and how computing worked there. In C, equals equals is always pointer comparison, right? You don't. It's not overloaded to do so or overridden to do something else. And so then in C, you have to use a function called strcomp to compare two strings. Uh, and so then, hey, for those of us who came up through that, this makes complete sense. But for a lot of people that have worked with JavaScript, worked with Python, worked with C++, you're used to having equals equals be a logical comparison. The designers of the Java programming language made a very deliberate decision to limit operator overloading. So you can't declare you can't override operators yourself. There's not something you can do in the language. Operator overloading was very out of vogue when Java was invented. In a lot of respects, Java is sort of an angry response to C++. C++ was still pretty immature in hindsight at that point. But the Java authors of the Java language felt that letting people override operators made it harder to read the code because when I see left shift, I want it to be left shift. I didn't I don't want to know. Oh, that's also how you like send stuff to standard out. I've always found that a little weird in C++. At first, I thought it was neat, and then it's like, but what does left shift really do? And then when you see like left shift with numbers, you're confused. It's like, well, this is an operator. It should be plus should be plus. The only operator that's overloaded in Java is the plus operator because you can use plus to concatenate strings or concatenate an object with a string. Which that's a reasonable thing to do, especially since the primitive types don't have methods. But no other operators are overloaded, which means that whenever you see or use equals equals, it is a pointer, a reference comparison, not a value comparison. And so then here, here the these are different instances because one is the instance was the reference, and so therefore they are not equals equals to each other. Let's see, another question. When we mentioned reference in Java, their interpretation is it being a new memory allocation? I would assume it's an alias to another variable like in Python. Yes. So when we say new, or when we declare a string constant, that instantiates a new object in the garbage collected memory. There's more details about it there, but yes, essentially what you're doing is you're saying new, which is like a malloc or a new in C++ or a new in any language. You are allocating new memory for it, and that is essentially a reference pointer. It's a reference, not so much a pointer, because you can't do pointer arithmetic in Java. It's just a reference off to it. Great. Okay, let's keep going. Okay, so here is there's a method on string called isEmpty, which is a nice convenient method that that determines whether or not the string, is empty. So is the empty string empty? True or false? Yeah. Oh yeah, and actually, you said 0, and that's another good reminder about Java. 0 and 1 are ints. They are numbers. They are not Boolean. So unlike in C, and I guess C++ too, because isn't C++ all cap null is just like 0. Again, this makes sense if you're an assembly programmer. This made sense in the 70s. It doesn't make sense, any longer. So in Java, let's see here. That's line 43. So line 43 is passing. Right. Line 44 is complaining about. If I say 1 for true here, it'll actually compile because it takes any object. But of course, it will fail because it expected a value of true because empty string is empty returns true. But what I sent it was a 1. So you can't use 1s and 0s or 0 and non-zero for for Booleans in Java. And so just to go through this quickly, the string 1, is it empty? No, it's not empty because it's string 1. Empty is 0 characters. A newly created string, do you remember what this one was? Is that empty? It is. As is an empty string, a new string created from an empty string, and of course then a new string created from the string 1 is not empty. Oh, that's right. Yep, now we're down on 52. Okay. Well, so I just want to pause here to just do a check. Is this making sense? Are you starting to understand what the koans are all about? The fact that we've got these little methods that have a couple of these assertions in them to help you learn about various types within the Java programming language, like here's strings. We'll see ones with arithmetic, with arrays, enums, and things like that. Any questions? Any sort of commentary here? Cool. Well, now uh, we could go on. I think you're getting the gist of it, though, and so I want to ask. I'm happy to do a couple more for you here and walk you through these. But if you've got it and you can be done, we can be done tonight. I wouldn't mind getting out a little early. I'm seeing some clapping, some smiles, some cheers. People are already heading for the door. Okay. Um, I don't mind. It's interesting. I said last week the pace might be a little bit off because in the summer the classes are longer in the winter, which is their time I teach, and so like normally by now it'd be time to go. But even though we have a little bit time left in class, don't worry, it'll get longer next time. I think next time we'll be doing some test-driven development, and I'm glad we're going to have plenty of time to dive into that. But I don't think I want to start. I don't want to jump ahead to next week. I want to let this sit with you all. Please, though, make sure to when you get home, if you've got time tonight or got energy tonight, great. Otherwise, very shortly, make sure you can create the Koans project. Make sure you can run it in your environment. Make sure to run the Java program on the same machine that you're editing the source code on. And dive into these because, again, we got through 23 of these tonight, not even 10%, and we spent like the entire night doing it. And these are the easy ones too. They get more challenging after that. So there's a lot to do with koans, but it's like little bits and pieces, and hopefully you get into a groove, and so you can go quickly on it. Great. Anything else for tonight? Nope. Okay then. Thank you all for your time. It was. I hope you enjoyed what you learned tonight. Have a good weekend, and I will see you again on Monday. Bye now.